not 2-4. Okay. Okay, guys. Good. Okay, guys, there's a class opener for you. What is the slope between the 2 points on the curve? Our goals today are going to be looking at tangents, velocity, and other rates of change. Okay, so there you go. You should be writing it down. What's the slope between those 2 points? Okay, you guys? What's the slope between the 2 points on the graph? Oh, I don't think I meant to hit the board. There we go. Because if you do this and you can do it, it's easy. Should remember this. Alex, did you write it? Oh, you did. Okay. You want to erase that for me? We can't get there. Yeah. Okay. Some people are really quick here. So you have f of a plus h minus f of a all over a plus h minus a. That's the slope. This is the average rate of change. Now, we also are going to have average value of a function. That's different. But they both say average. So it's so easy to get this mixed up with the integral version. This is not. This is the slope. So if you want to find the average rate of change of a function, you just find the slope at the 2 endpoints. It's as simple as that. Now, what's a rate of change? Because I know I said it kind of fast. Because we're talking about rates of change. And if you look at the exam, there's a lot on rates of change. So you better know what it is. What's a rate? That's, in this particular case, it's change in y over change in x. What is a rate? A rate is a ratio. So when we want to find a rate of change, I'm going to find a ratio between 2 changes. How does x change? How does y change? It's that ratio. And the reason why implicit differentiation is hard for some students is they don't realize that a derivative is a rate of change. So you have to talk about how something changes as something else changes. It's not just the change in y. It's the change in y when you change your x. So if you change your x is this way, your change in y is that way. And there's change in x. So you have to have with respect to. Okay, definition. Tangent line to the curve, and this should be f of a. It's the line to the point with the slope. How do you find the slope? I want the slope at a particular instant. So I want the slope maybe right there. By the way, look at that. The tangent line touches the curve in one place, but it also crosses it. It might bother you. So how do you find the slope at one particular point? What do you have to do to this? This is the slope of the secant. Do you remember that? And so I want the instantaneous. You're going to, what go to 0? Okay, so the instantaneous is the limit as h goes to 0 of f of a plus h minus f of a, and we can simplify that denominator to be h. So you get a hole when h is 0, you get 0 over 0, because you can't take the slope at a single point. It doesn't make sense, does it? You have to have 2 points. So what we're trying to do is we do take 2 points, and we get really close to that single point, and we say this is our limiting value, whatever that is. Now, the average rate of change would be like going to Chicago, and let's say it's 400 miles, and let's say it takes us 8 hours. What's my average rate of change then? 50. 50 miles per hour. Well, what's happening as I drive to Chicago? Here's our time, here's our position, I start off at a constant rate of change, but then the car runs out of gas, so I got to stop, put gas in, and then I go another constant rate. Hang on for a second. And then it gets flat again. Okay? That's the average. Will be when you bring that up. Thank you. Okay. So the average rate of change here is the slope between this point here and this. It's the slope of the secant. Now, does that mean I'm traveling 50 miles per hour the whole time? No. My instantaneous rate of change might say, what? Now, your instantaneous, this is your speedometer. Am I going to go faster? If I'm averaging 50, how fast am I really driving? Because remember, I'm stopping. I'm probably going 55 or 60. So I like to travel out west, and the speed limit out there is 75. I think the best I've ever gotten for my average speed is 65 if I go 75. It's really hard to average a high speed because you stop. Because you have to average in those times when you stop. So your speedometer is a derivative. And actually, it is an average rate of change. They're just measuring the times really close together to get your speed. In fact, some of the newer cars actually have, what do they have on there? They have your mileage on there, but then they also had something else on there.
What was the thing you talked about in the class?
Hey, shh. Eric, I can't hear him.
Like a court case where some car was that like intermediate value theorem?
That's the mean value theorem, which isn't in this section. But you guys, if I average 50, don't you think there's someplace in between here where my speedometer will read 50? Yeah, there it is. That's the mean value theorem. So there's a court case, and I think I still have it up on the website, where a guy was, I think, charged for speeding. I don't exactly remember. But he used calculus to prove his innocence. I don't know. I'd have to read it again. It's been a while since I read it. But the point is they used the calculus to do it, which is really cool. Okay? Well, I have to go read it. I don't know. Oh. They can calculate the distance they travel. So if my average velocity, if I have an average velocity of 65, then that means I'm going 65 sometime. Yeah. So they use this math all the time. It's kind of cool, but most people don't understand how that works. Okay. How do you write the equation of a tangent line? You guys know from the exam, Lizzie, that you took last year. How do you write the equation of a line? It's y minus y1 equals mx minus x1. In fact, the chief reader, he wasn't there last year because they only worked for 3 years. But the year before, he said, I would really prefer to see this. And that's linearization. It's writing the equation of the tangent line to use that to estimate a y value. And this will look familiar to you later on when we get to chapter 8. Okay, so it leads us into Taylor series. Now, how do you find the slope? You guys, what's the slope at f of a? I'm being redundant. It's the limit as h goes to 0. It's f of a plus h minus f of a all over h. And another word for that is a what? Derivative. Okay? So derivative and slope are the same thing. Remember that? And what happens if you repeatedly zoom in on a point on my graph? If I have a nicely behaved curve, I get a line. If I don't have a nicely behaved curve, then I don't get a line. And I have one on my calculator that we zoomed in on. It was the absolute value. We could do that again if you want. Oh, okay, guys. There is another form for slope. If I define my function like x, f of x, can you read that okay? And a, f of a, what's the slope there, Eric? F of x minus f of a all over x minus a. I like that form better. I see slope. I see the change in y. I see the change in x. And that's what they're going to do in science class.
Is this squeeze term on the cosine?
No? Okay? And that's the average slope. So this is the average. What's the instantaneous? Now it's a little bit different. It's f of x minus f of a all over x minus a. I'm going to take this point. I'm going to actually want to do my derivative up here. It doesn't really matter. But I'm going to take that point, and I'm going to drag it on along the curve. So what's happening to, well, actually, I said that wrong. I want to do the other one. I'm going to take this point up here, sorry. What's happening to my x? I'm going to drag it on the curve. X is doing what? Okay, what's x doing? Getting closer to a. So x approaches a. Is that different than our other definition, Grant?
No.
Not really. Because this distance here is h. So I have a here. I'm going to get to x. What's x equal to? Or Eric? What's h equal to? H equals x minus a, right? You solve for x, x equals a plus h. So if I put in x equals a plus h here, I'm going to get an h in the denominator. There's a plus h. Now it looks like the other form of the derivative. That's it. Sometimes this form is easier to handle algebraically. It just depends. Okay, how do you find average velocity? Grant, how do you find average velocity? B averages, no, it's the change in the position divided by the change in the time. If you have the velocities, that's when you integrate. But if I'm not given that, we don't have it right now. So what's the instantaneous velocity? It's the limit of the change in your position over the change in time as what? The change in time to approach is what? 0. So how do you find the average rate of change of a function? You just find the slope. Should all be familiar. How do you find the instantaneous rate of change? It's the derivative. What's the difference between average and instantaneous rate of change? Average is over what? Over an interval, right? And the instantaneous is at an instant. We can't actually calculate that because I need 2 points to calculate that slope, and I can never get 2 points. Not going to happen. Grant, question? Nope. I think I'm almost done. I might be done. That's it. I don't know if those are the right homework problems on the bottom of the sheet. Yeah, go by the assignment sheet. Okay? And that's all there is. So we have a little homework quiz today on 2.3, and then you have a half hour, so that'll work.